guys, welcome to today's class, and in this very video we are going to be talking about leucopoiesis, which means the production of leukocytes. So without wasting much of our time, let's get started. Yeah, welcome back. Now, straight to the topic of the day, leucopoiesis. Leucopoiesis. Now, what is the meaning of that? Yeah, leucopoiesis is actually from two words as usual. So the first one is leuco, that we have right here, and it is from the word leukocyte. Leukocyte. And leukocyte strictly means white blood cells. White what? White blood cells. And when you say poiesis, you've known that since our erythropoiesis days. Poiesis means formation or production. Formation or what? Or production. Cool. So when they say leucopoiesis, leucopoiesis strictly means the production or formation of white blood cells. And that is a straightforward definition of what? Of leucopoiesis. Leucopoiesis is the production of what? Of white blood cells. Now, if you want to understand leucopoiesis, we said it is the formation of white blood cell. The question is, what is white blood cell itself? Now, I assume you've known that before. But just for a quick recap, white blood cell is actually a part of the blood. We said the blood itself mainly is made up of two things. We said the first one is called the plasma, and the second one are called the what? The blood cells. Or you call them the what? The formed elements. Now the point is that the plasma, we know what they are. They are produced by the liver, and they are what? They are yellowish in color. So the point is that talking about the blood cells, we have just three types. Talking about the three types of blood cells, 1, 2, and 3. So we have the red blood cells. Red blood what? The red blood cells. And then we have the what? We have the white blood cells. White blood cells. And finally, we have the platelets. The what? The platelets. So these three guys are the three blood cells that we have. And they all have another name. For these red blood cells, you can call them erythrocytes. We've done that before. Erythrocytes. And for the white blood cells, you can call them the what? The leukocytes. Leuco what? Leukocytes. And the platelets can be called thrombocytes. Thrombocytes. Cool. Now, what do you think I want to teach you from here? What I want you to understand is that these white blood cells, their main function is to fight infection. To fight what? To fight infection. So when you get sick, that is when they get into action most of the time. Now, from here, we've talked about red blood cells in detail, so nothing to say about these guys for now. Now, the person we are dwelling on is the white blood cells. Now, talking about the white blood cells, we have a lot of them in the human body, but then they are broadly divided into two groups. It's as if they are saying we have a lot of human beings in this world, but then we can just categorize them into three, like the white, the black, and maybe the yellow or something. So using color. So the point is we have a lot of white blood cells in the human body, and the point is they are grouped into what? Into just two. The first one are called the granulocytes. Granulocytes. And the second one are called the agranulocytes. Agranulocytes. Now the point is that when they say granulocytes, they are the types of what? White blood cells that possess granules. That possess what? Granules. But when they say agranulocyte, A actually means absence. So when you say agranulocyte, it means they do not have granules. But do not write that. It's a lie. They just give us that just to understand it literally. So if that be the case, what does a granulocyte mean? That's an assignment for you. So find that out yourself. Now the point now is that the granulocytes in the human body are divided into three. Or we have, let me say, three groups of granulocytes. And the acronym is BEN. B, E, and N. So the B is basophil. Basophil. The E you have here is eosinophil. Eosinophil. And then the N you have here is neutrophils. Neutrophil. Cool. All these guys are looking at, they are white blood cells. But then they are what? They are granulocytes. Now, talking about the A granulocyte, we have just two A granulocytes, two groups. And the acronym is L, M. The L is lymphocyte, and the M is monocyte. As simple as that. Which means the lymphocyte and the monocyte are A granulocyte. As simple as that, guys. So this is what? The divisions of the white blood cells. Now, once you know this, you can go straight up now into the development of the white blood cells. So, I'll be right back. Yeah, welcome back. Now, talking about leucopoiesis, we're going to start it exactly the way we started erythropoiesis. Remember, in erythropoiesis, I called it a mechanism which requires a stimuli to what? To get into place. Exactly the same thing is happening for what? For leucopoiesis. It's also a mechanism. And the point is, it must have some stimuli. Now, we'll start from that. What are the stimuli for what? For leucopoiesis. It means what are those things that can happen? What are the changes that can get into place before our body starts to produce white blood cells? It's very simple. You can always think of it like that of the red blood cells. We say whenever there is a reduction in oxygen carrying capacity, or whenever there is a reduction in the total amount of red blood cells. So the point is, the function of red blood cell is to transport oxygen, right? But the function of these guys, the white blood cells, is to fight infection. So the point is, if someone has a chronic infection, so that is what? Presence of infection. Presence of what? Infection. So white blood cell, there will be a need for them to be produced to fight against the infection. And apart from that, when we're talking about the red blood cells, erythropoiesis, we said a reduction in the total count of red blood cell can trigger their production. Same thing for white blood cells. So the point is, a reduction in WBC count, in white blood cell count, when there's a reduction in the total amount of what? White blood cells in your body. So the body is going to naturally produce more. As simple as that. Now, when all this is happening, what happens next? Exactly the same thing is going to happen. All these stimuli, what they are going to cause is that there's going to be the transmission of impulse, some kind of body tissues, but mainly the reticuloendothelial tissue. So an example of that is a lymph node, even display sometimes. So the point is mainly, we'll always depict this with lymph node. So when impulses are sent to reticuloendothelial tissues like the lymph node, they are going to release some kind of chemical, and that is interleukin 3, interleukin 5, and something called granulocytic. Let me just write it in short. I put the full somewhere else. So granulocytic colony stimulating factor, or a granulocytic, let's make this small g, colony stimulating factor. Now guys, the question is, what are all these things here? Just what are they? The point is, you see, IL-3, it means interleukin 3. IL-5 means interleukin 5. Now you see this GCSF, it means granulocytic colony stimulating factor. Now, We have just two things in this box now. Interleukin is for IL. GCSF. This GCSF, it means granulocytic colony stimulating factor. Now, what about the A here? You can guess. If we have granulocytes, that gives us granulocytic colony stimulating factor. So, it means the AG is going to be for the other one, which is the A granulocytic colony stimulating factor. Solved. Very easy. Now, at this junction, what are these guys going to do? These guys, what they do, I won't go there for now. Instead, I'll go to a revision of what we've done in the last scene. And that is what? The types of white blood cell. Let's come right in. White blood cell. We said we have what? We have the granulocyte, and the what? And the A granulocyte. A granulocyte. We said the granulocyte are the vein, the basophil, eosinophil, and the neutrophil. And here we call them the what? The LM, lymphocyte, and monocyte. Cool. Now, after that, what do we have? And why are we doing that? You will get it soon enough. Now, the point is that, you see, let's assume that we want to create monocyte. Firstly, I want to always put these steps at the back of your mind. And what are these steps? That is what we have right here. Development of these guys will always pass through a blastic level. Let's say a blast. From blast, it goes to pro-blast. And then it goes to site. Excuse me? No, it goes to pro-site, not pro-blast. Pro-site. But something starts before this as well. So dash blast. Now guys, what is the meaning of that? You soon understand now. Let's pick the monocyte for example. Now watch out. If there is a reduction in the count of what? Of monocytes, what do you think will happen? A reduction in the count of monocytes, let's denote that with M. It will lead to the transmission of impulses to the what? Reticular endothelial tissues. And they are going to release what now? They will release interleukin 3, interleukin 5. And one of these two, either granulocytic colony stimulating factor or a granulocytic colony stimulating factor. And the question is, which one do you think they are going to release? Since we are forming an A granulocyte, which is monocyte, we are not going to need GCSF in this case. What we need is a granulocytic colony stimulating factor. Beautiful. So the point is, if you are trying to talk about the production of monocytes under leucopoiesis, whenever there is a reduction in the count, impulses are sent to the what? To the reticular endothelial tissues. And what those people do is to release interleukin 3, interleukin 5, and a granulocytic colony stimulating factor. Simple. Now, once these guys has been released now, so once they've been released, they are going to collectively go to where? You know where? These are representing the erythropoietin for us in erythropoiesis. So they are going to act on the what? They are going to act on a cell inside the what? Inside the bone marrow. So let's assume this is a bone now. So that big cell is there waiting for us. And that is hemocytoblast. The hemo what? Hemocytoblast. Now, when these guys, when they stimulate hemocytoblast, because it is trying to produce monocytes, is going to divide into a cell called myeloid stem cell. Myeloid what? Stem cell. So let's assume that this is our myeloid stem cell. Now, what do you think the myeloid stem cell will divide to next? That is where the stages comes in. Now, look up. Come right here. The first cell, the myeloid stem cell, will divide to, if we are trying to form monocytes, is dash blast. Now we guess, what's a beta blast? Very simple. Since we are trying to form a monocyte, myelin stem cell will divide to form a new cell. And this new cell will be called monoblasts. Mono what? Monoblasts. As simple as that. Which means we picked mono, which is part of the name, and we swapped it with the what? With the first stage here, which is blast. Dash blast. As simple as that. So if you can guess this, tell me, what are you going to have next? After dash blast, it becomes pro dash site. Now, this monoblast is going to divide into a new cell again. And that cell is going to divide to next is pro. Now, what are you going to put here? The same thing, this mono, pro mono. But pro mono what now? As in pro mono what now? Pro monocyte. Let's put the site right here. So guys, you see we are only using this kind of tree to get through these things. So the point now is that this is our first format, dash blast. Second one is pro dash site. As simple as that. And then you know the next thing that is going to become. That is your what? Your dash site. Now, this is going to become the normal cell that you are looking for. And that is the monocyte. As simple as that, guys. And we are done talking about the development of monocytes. As simple as that. So this thing is actually not difficult. Guys, you see, I'm doing this so you can understand some certain things. We are going to represent the diagram in a single page as in on the board. We are coming back with all these things again. But I want you to understand the narrative. I want you to understand the cheat, the template, the prototype for doing all these things. So when I bring the gigantic diagram on the board, it won't look strange. You understand it once. Now, let's play with this guy one more time. This guy, lymphocyte. Now, guys, tell me. If we want to produce lymphocytes, the stimuli is going to be a reduction in its count, right? So if we have a reduction in what now? Lymphocyte now. L, reduction in lymphocytes. So what do you think will happen next? What will happen is actually pretty simple. The point is, impulses are going to be sent to the reticular endothelial tissues as well. And then they are going to release exactly the same thing. Because that is what we need. Now, this guy is again, they are going to stimulate the what? The hemocytoblast. When you stimulate the hemocytoblast, is the hemocytoblast going to release the myelin stem cell again? No. Instead, it releases a new cell called the lymphoid stem cells. Lymphoid what? Stem cells. The lymphoid stem cell. Now, the lymphoid stem cell is going to divide into what? Here, the myelin follows the what? Our cheat. Dash blast, pro dash site, and dash site. Now, the point is, exactly the same thing will happen here. We are trying to form a what? A lymphocyte, right? So the point is that this guy is going to divide into what? Dash blast. So it's going to become lymphoblasts. So we are trying to form a lymphocyte. So it will become lymphocyte first. Let's assume this is a lymphocyte. A lymphoblast rather. From the lymphoblastic level, it will turn to what next? You can guess. Just take a look at the format. Pro dash site. What is that going to be? It will form a new cell. And you can call this new cell what now? Pro dash will be your lympho. Pro lymphocyte. As simple as that. Pro dash site. And finally, you are going to form your what? The cell you've been looking for. And that is your what now? Dash site. Which is lymphocytes. And then the production of lymphocytes is done. Cool. As simple as that, guys. All you have to remember is to know the kind of factor that will stimulate the hemocytoblast and the kind of cell it is going to produce. Now the question is, what about the basophil, eosinophil, and the neutrophil? We are dealing with them exactly the same time because they belong to what? A single stage, a single class, rather a single group, which is the granulocyte. Now, let's take a look at what? At this granulocyte. When there is a fall in this count of what? In the count of this basophil, eosinophil, neutrophil. Tell me, impulses are going to be sent to where now? To the reticular endothelial what? Reticular endothelial tissues. And now they are going to release what now? They won't release this group again. What they release is interleukin 3, interleukin 5, and granulocytic colony stimulating factor, SOFT. They are not going to use a granulocyte because they are not trying to form a granulocyte. which is the lymphocyte and the what? And the monocyte. So they are trying to form a granulocyte. That is the reason why we are not using what? AGCSF here. As simple as that. And then these guys collectively will act on what? They will act on the what? On the hemocytoblast. And they will tell the hemocytoblast to divide into what? Is it the lymphoid stem cell or the myeloid stem cell? They are going to tell it to divide into the myeloid stem cell. So they tell it to go to the what? To the myeloid stem cell. This is where I will rub the board. But I will tell you the reason why they are acting to become the what? The myeloid stem cell. It is simply because the myeloid stem cell is responsible for producing monocytes. That is one. Remember your erythropoiesis. That is your what? Erythrocyte, the red blood cell. These guys form them as well. And then these guys also forms the granulocytes. Granulo what? Granulocyte. Which is your what? Your vein. As simple as that. So the only lineage that these lymphocytes, that this lymphoid stem cell produce is the what? The lymphocyte. So lymphocyte has only a single precursor. It doesn't share precursor with the others. Red blood cell here is sharing its precursor, its ancestor rather, with what? With the myeloid stem cell. With the granulocyte. The red blood cell, granulocytes, and the what and the monocytes, they come from the same forefather. So the only person being produced alone is the what? The lymphocyte, produced by the lymphoid stem cell. Beautiful. Now, we wrap the board, and we are going to reinterpret everything again in a different diagram, talking about the function of each of these blood cells. So, I'll be right back, guys. Yeah, welcome back, guys. Now, I'm going to draw a diagram on the board illustrating the stages, the processes of what? Of leukopoiesis. So, just give me some minutes. I'll be right back. So, guys, this is actually going to help us to visualize the process of leukopoiesis one after the other. Now, let's start with this. We know that our white blood cells can either be a granulocyte or the what? Or the A granulocyte. So let's talk about the A granulocyte first, which is the lymphocyte and the what? And the monocyte. So an example of white blood cell is lymphocyte. Lymphocyte. Now, if this is the lymphocyte, how do you think it develops? Now, the stimuli that will bring about the production of lymphocytes is a reduction in its count itself, or infection. That will be the what? The stimuli. Now, after that, the next thing is, which chemicals do you think is going to be released if we want to produce lymphocytes? If we want to produce lymphocytes, we are going to need something which is the what? Interleukin 3, interleukin 5. And what? Is lymphocyte a granulocyte or an agranulocyte? It is an agranulocyte, so therefore you are going to be needing agranulocytic colony stimulating factor. As simple as that. So, after this has led to the production of what? Of interleukin 3, interleukin 5, and the agranulocytic colony stimulating factor. All these guys, these chemicals, they are going to go into the what? Into the bone. And the question is, what are they looking for inside the bone? They are going there to meet a certain cell right here. And we know, let me put the cell right here, somewhere around here. So this is the cell now. And this big cell is called hemocytoblast. Now the point is that if you are producing a lymphocyte, that can occur due to a reduction in the count or infection, and then the impulses are going to be sent to organs like the reticuloendothelial tissues. We've talked about that before. That is why I left it out here. So the point is, these guys are going to be released and they will act on the what? On the hemocytoblast. And when they act on the hemocytoblast will divide into a certain cell. And that cell is called the lymphoid stem cells. The lymphoid what? Lymphoid stem cell. And what will happen next? The lymphoid stem cell is going to divide through a series of stages to form something. And the question is, what is that? I have told you before. Blood cells, they used to pass through 3 stages mainly. The first one is the dash blast stage. Dash blast. Second one is pro-site. And the last one is what? Is dash site itself. Now the point is, the lymphoid stem cell is going to divide to form a what? Dash blast. It will form a new cell. And this new cell is going to be called dash blast. We want to form a what? A lymphocyte. So lymph will be dash. So this guy will become the lymphoblast. Lymphoblast. Simple. And what next? From there it is going to divide to pro-site. That will tell you it will become what next? It is going to become what? Pro, then you add the lymph here, site. So it becomes pro-lymphocyte, pro-lymphocyte. And finally, it becomes what? Finally, it's going to become dash site, which is what you're trying to produce, lymphocyte. So it becomes a lymphocyte later. Lymphocyte. So, lymphocyte. As simple as that, guys. Now, that is the production of lymphocytes. Apart from that, we have another cell called the what? We have the monocyte. Monocyte. Now, if you want to produce monocytes, the stimuli is also a reduction in what? In monocyte level. Or during infection when they are killed. So, for monocyte now, if there is a reduction in monocyte, impulses are going to be sent to the what? To the reticular endothelial tissues as usual. And then exactly the same thing is going to be produced. Because it is also a what? An granulocyte. So, as simple as that. So, after that, this chemical again is going to act on where? It's going to act on the hemocytoblast. Now, the hemocytoblast will respond by dividing into which cell? I've told you in the last thing that lymphoid stem cell is only meant for lymphocytes, and that is its only function. So obviously, if you want to produce monocytes, impulses are going to be sent to the what? To the hemocytoblast. And hemocytoblast is going to divide into a cell called the myeloid stem cell. Myeloid what? Myeloid stem cell. Cool. And now, when we have the myeloid stem cell, what will the myeloid stem cell divide to? Now, remember, everything happening inside this place is happening inside the bone. So, the bone production is occurring within the bone marrow. All these things, we assume them to be what? Every space you can find there, we assume it to be the bone. Now, the point is that the myeloid stem cell is going to divide to a new cell. And that new cell is going to divide to, is actually called, I'll try to bring it up like this. So, now, we want to form a monocyte. The first stage is what? Dash blast. You already know it is going to give you what now? It is going to firstly divide to form a monoblast. Mono what? A monoblast. And from the monoblastic level, it's going to become what? Pro-site. And that will give you the next cell called the what? That is the pro-monocyte. So it becomes the what? Pro-monocyte. Pro-monocyte. And from there, it's going to divide to form the last one, which is what now? Dash site. So then, you have a new cell right here. So, and this is going to give you what? A monocyte. So, monocyte. As simple as that, guys. We are done with that. Now, what about the A granulocyte? The A granulocyte includes the basophil, eosinophil, and neutrophil. So, if you want to produce these, what is going to happen? Now, they are all granulocytes. You can have the same stimuli for them as well. So, infection or what? Or reduction in the count. Reduction in the count or what? Or infection. So, same stimuli. The point now is that what is the chemical that is going to be released there for them? The chemical that will be released, that is interleukin 3, interleukin 5, and the granulocytic colony stimulating factor. As simple as that. Now, these chemicals, so what are they going to do? They're going to act on the what? On the hemocytoblast. And when they act on the hemocytoblast is divided into either the myeloid stem cell or the what? Or the lymphoid stem cell. Now, let me ask you, which one do you think the hemocytoblast will divide into? Obviously, it's going to divide into what? Into the myeloid stem cell. We said this is the only cell that the lymphoid stem cell produces. As simple as that. So the next thing is that the myeloid stem cell will not divide into what? To divide into the what? Sorry, the hemocytoblast rather will divide into the myeloid stem cell. And after that, the myeloid stem cell will divide into something else. And the question is, what is that thing that the myeloid stem cell will divide into? What is the name of that cell? We are going into stages again now. The point is that the first thing is dash blast, right? But we want to produce three things. You can't say basoblast or eosinoblast or nitroblast. A single cell will divide to all these three guys. So the point is, that cell that will divide to all these three guys has a blast, but it is not of any of their names. It is myello. So the point is, myeloid stem cell will divide into myelloblast. Myello what? Myelloblast. As simple as that. And the question is, after that, what next? The next thing is very simple. Once you know that, the next thing you are going to after the blastic level is the site, pro-site. Then you follow the myeloblast to turn what? To turn to a pro-site. If we are doing that, know that this cell is going to divide into three. So, three groups. The first one is right here, the other one right here, and the last one right here. Now, what do you think I'm going to call their names? You see, the first one here, let's assume it is the basophil. It is the one that is going to form the basophil later. So you call it basophilic. Basophilic. Now, it won't be basophilic myeloblast because myeloblast divides to form them. After myeloblast, if you are putting my L right here, my L, that will give you pro-myelocyte. So the point is, this is basophilic pro-myelocyte. Pro-myelocyte, but not the end. Another thing is that this guy is going to be called what? If you are taking it from eosinophil, that is eosinophil pro-myelocyte. And tell me after that, the next thing we have is what? Is neutrophilic pro-myelocyte. Cool. And after that, know what will happen next. The next thing is that they are going to divide as well to form another cell. And that cell they are going to form individually. So, this guy will form something new. The point is, they are meant to form things like what? Like myelocytes right now. So, you can take this to be a what? This is going to be basophilic myelocyte. Basophilic myelocyte. And then, this guy will become what next? This guy is going to become something like what? Eosinophilic myelocyte. Myello what? Myelocyte. And finally, this guy is going to become what? Neutrophilic myelocyte. Apologies. Cell. So, neutrophilic myelocyte. Neutrophilic. I'm sorry guys. So, do not have enough space. Myelocyte. Myelocyte. As simple as that. And the point is, after that, where are they going to next? You know already. Since we are done with all these stages, they become their natural cell. Although they become band cells firstly, but leave band cells alone. The point is, after this guy becomes basophilic myelocyte, it will later become this. So, it will later become his normal cell. The normal cell that it should be. So, and that is the basophil. Excuse me, basophil. Basophil. And the myelocyte here, eosinophilic myelocyte, will also change to transform to the normal cell that it should be. And that is something like, so this guy is going to become what now? Eosinophil. Eosinophil. And finally, this guy is going to become what? This guy is going to become neutrophil. The neutrophilic cell. So, neutrophil. As simple as that, guys. So, if that be the case, that is the development of what? Of these white blood cells. Now the question is, when all these blood cells, when they get into the bloodstream, what do they become? What's their function? Now, to understand that very well, I'm going to take you somewhere else firstly. And where is that? Let's talk about development of the last blood cell. If you take notes, you understand that we've created the red blood cell, the white blood cell, but we are left with platelet alone, right? Cool. Now, how do you think platelets are formed? For platelets, for example now, let's demarcate this place for platelets. Platelets. So if you want to form platelets, let me just rub all this enough. Let's assume that you want to produce the platelets. Now, impulses are sent to what? Impulses are sent to mainly two organs. In this case, mainly the what? The liver and the kidney. So the liver and the kidney are going to release a chemical, and that chemical is called thrombopoietin. Thrombopoietin. Just like erythropoietin. Now, the thrombopoietin is going to act on what? On the hemocytoblast. And the hemocytoblast will divide to form what? The myeloid stem cell. Now, what do you think the myeloid stem cell will do? The myeloid stem cell will divide to form a big cell. And that big cell is just like following this stage as well. However, its name is So, megakaryoblast. Megakaryo what? Megakaryoblast. The blast is here. Dash is megakaryo. And from the megakaryblastic level, it divides next to form something new. And that thing you can get, it forms pro-site. That will give you another cell, which is called the dash is what? Megakaryo. So, megakaryo, but what now? Site. Pro-megakaryocyte. And finally, from that stage, it becomes something new. And that's another large cell, very large cell, called dash site. Now, we already know what it is actually, and that is megakaryocyte. Megakaryocyte. As simple as that. How does megakaryocyte now become the platelets? We'll talk about that in the next thing. So, just for a quick recap, so we can understand far better. You see, we said, if you want to form the granulocytes, which are the lymphocytes and the monocytes, they have the same stimuli, they release the same chemical, and then the chemical, it is going to stimulate the what? Hemocytoblast to release the myeloid stem cell. Sorry, for the granulocytes, it can release either the myeloid or the what? Or the lymphoid. So if it releases the lymphoid, it is planning to form the lymphocyte at the end here. So this is the end stage right here. So, and if it's releasing what? Monocytes, it forms the myeloid stem cell to release the spinal cell right here. So called the monocyte. Now if you want to produce the what? The granulocyte. Say interleukin 3, interleukin 5 and granulocytic colony stimulating factor, they are going to stimulate the hemocytoblast, but to form the myeloid stem cell. The myeloid stem cell now will divide into something called the myeloblast. Myeloblast will become 3 cells: basophilic promyelocyte, eosinophilic promyelocyte, and neutrophilic promyelocyte. And they all become the what? Basophilic myelocytes. They all become myelocytes generally. From the myelocytic level, they become their respective cells. The basophil with just a single lobe, the eosinophil with 2 lobes, and the what? The neutrophils with 3 lobes. That doesn't mean the number of lobes actually is their perfect number. The point is, if we say 1 lobe here, so The point for these two rather is that it can be 2 to something else. Most of the time, textbooks used to say 2 to 4 or 2 to 5. And this guy is 3. It's like 3 to 6 in most of Facebook, in most of textbooks actually. So that one aside. So I'll rub the board. And the next thing I'm doing is to understand the function of each of these white blood cells. If you understand that, leukemia gets easy. So I'll rub the board and come back with that. So I'll be right back.